Hi, you guys. This is part two of the last video that I did. I would say that I'm going to be more consistent with making videos, but we all know that every time I say that, I never do. So I'm not even going to try to make excuses anymore. Okay. But I did, if it's worth anything, I did spend this not whole weekend. I mean, I spent the whole weekend cleaning and whatever because I'm out of town like almost every weekend this month and next month. But I did solve like five different problems I want to post, or three problems, but like five parts. So hopefully I'll get to start posting those, but I don't know. We'll see. Okay. Anyway, so this is part B of problem 5.7. Find the tension in each chord in the figure if the weight of the suspended object is W. Okay, so um, let's go ahead and write this out. Okay, so part B, right? We want to solve this over here. So we have tension in chords A, C, and B, and we want to figure out what those are, right? So I'm just going to go ahead and write that down. So you want to find out tension A is equal to what, tension B is equal to what, and tension C is equal to what. Okay. We don't have too many givens, but what we can do is we can go ahead and draw this problem a little bit better over here. So we can maybe get like a bit of a better idea as to what's happening in this picture. So we just have some object hanging. I'm going to draw it as a box, like for sake of simplicity. Okay, and then okay, then we have this over here, and this is, let's see, this is 45 degrees. All right. And then this is 60 degrees. So what we know is that we have this, I mean, the weight of this box is, obviously downwards, the force of gravity weight downwards. And then we have an equal and opposite uh, force, which is holding this object in place upwards, right? And that's going to be force of tension, and that's going to be tension. Let's just call that TC, like we did over here for sake of consistency, right? And you want to figure out what that is. Also, how do I know that TC and like W are opposing each other? Because we know that this object is just suspended and in equilibrium, right? If it were falling, then it would be like a different story, but it's just in place. And if it's in place, that means all the forces are sort of balanced out with each other, right? Okay, and then we're going to look at like this point over here, right? So this point is also in equilibrium, right? Because it's not accelerating if it's in place. That means that all these forces, so T, TA, TB, and TC are balancing it out so that altogether over here, this is like zero, right? All right. So exactly what is this TA and TC, right? So we have to break this down into components, okay? So there is a force component of tension that pulls upwards, and then there's also this component, this horizontal component of tension A, and then similarly with tension B, right? So tension B horizontal, and this is also going to be tension B, um, you know, actually, you know what? I'm gonna draw it differently, actually. Okay. So I'm going to draw it differently. The reason I did that, I mean, it still stands that this is going to be the y component, and this is going to be the x component, and then this is going to be the y component, and this is going to be x component. And then this is going to be just the y component of TC. But I don't want to draw the arrows just yet because first, what we want to do is we want to set up some sort of coordinate system, right? Because like what's to say what's positive and negative? We don't know until we set up our system. So let's do that. So let's just say that this, as per usual, if you watch my other videos, right is positive and up is positive, right? And that means that this we can say that, this tension is downwards, right? Then we can say that this tension is in this direction, tension is pulling it in, the opposite direction, and tension is also pulling it in this direction. And then we can just say, then we can draw our arrows to point to, um, the arrow, right? Okay, so that's what we want to do. Now, how do we actually figure out TA, TB, and TC? Well, we have to come up with equations, right? And how do we come up with equations? Well, first we have to recognize that all the forces in the x direction, sorry, this with capital X. Okay, sorry, give me a second. My mom is calling me. Let me just pause that. Okay. All right. So what we know is that all of the forces in the x direction are equal to 0, right? For this over here, we know that all the forces in the x direction are equal to 0. How do we know that? Again, it's not like the knot's moving around, right? It's not accelerating, it's in place, which means that it's in equilibrium. So the forces in the x direction equal to 0. Forces in y direction also equal to 0. Why? Because it's in equilibrium. Okay, so now what do we do? Now we have to come up with equations that are of all of the forces in the x direction, right? Because those are equal to 0. So then we'll have a system of equations, and then we can solve for TA, TB, and TC, right? Okay, so let's do that. Okay, so let's go ahead and start with x, okay? So for x, we know that this is the x component, right? So we can say it's minus a sine 60, right? Because this is 60, so that blue line, that dark blue line is going to be a sine 60. And it's in, this direction, which means it's negative. So it's going to be minus a sine 60, right? And then plus b cos 45, right? Because cos is close, sine is the other line. Plus b cos 45 is equal to 0. Okay? 1. Let's just I like the trick I was taught in high school is just to number your equations as you go, or else it just gets super messy, right? Okay. So it's just easier to do it that way. All right, now let's do y. Okay. Now y is going to be what? So let's start with a again. It's going to be this downwards a component, right? So also, sorry, just for sake of simplicity, instead of writing like TA, I'm just writing A. Instead of TB, I'm just writing B, just because it's a little bit faster for me, okay? All right, so then let's do okay, so it's going to be this over here we have to write out, right? Okay, so um, minus, right, again, because it points downwards, it's going to be minus A cos 60, right? Okay, plus b sine 45, right? And then minus c, because that points downwards. Minus c is equal to 0. All right, so now we have equation 2, right? That makes sense. And again, because instead of writing TC, I'm just writing C, okay? But you get the point. Okay. Um, all right. Okay. So now we have 2 equations, 3 unknowns, right? But that doesn't work. We need 3 equations if we have 3 unknowns. So let's go ahead and come up with our last equation. Well, remember when we talked about how like this is also like this is also a system that's in equilibrium. So we know that TC minus W, because W points downwards, is equal to 0, right? So we can write that down as our third equation, right? So we can do C, because that's upwards, minus W is equal to 0. Also, you might ask, so, hey, didn't you just say that TC pointed downwards and now you're saying TC points upwards? Well, that's tension for you, right? So tension is going to oppose um, the direction where like one force is already facing, right? So if a box is downwards, then tension is going to pull upwards, right? It's just going to oppose an already existing force because remember that like that's what tension is, right? So um, when you pull a string, tension, and you hold it like sorry, when you hold a string taut, there's tension in both directions. So that's how we know that tension is going to be where we said it was in each scenario. Okay, now all we have to do is solve this system of equations. Okay, so let's go ahead and do that. All right, so let's start off with our first equation. And let's just replace 3 into 2. Okay, minus a, okay, yeah, minus a cos 60 plus b sine 45 is equal to w, right? Because c is equal to w, which we just replace here, right? You get the point. That one's, you can work that out. Okay. All right. Now let's recognize that, and we can maybe even call this like 4 just for sake of simplicity, or like for sake of organization, not simplicity. Okay. We also know that b cos 45 is equal to b sine 45, right? Because cos 45 is equal to sine 45. We know that, so we can use that to our advantage, right? So that means let's recognize that um, b sine 45 over here is equal to w plus a cos 60, right? W plus a cos 60. Now we know that we have this equation over here, right? But we want to figure out, we want to basically isolate so that we only have one variable in here. So we can use like substitution, right? So let's substitute this, right? Because you said b cos 45 is equal to b sine 45, and b sine 45 is equal to w plus a cos 60. So let's use that to our advantage. All right. So minus a, and we can call this 5, right? So minus a sine 60 plus w plus a cos 60 is equal to 0, right? So what we did here to here was, well, I explained what we did. I don't need to say it again. Okay, just because I don't want to run out of time for this video. You can rewind and watch again. Okay, so now what do we do? Now we know that we can isolate for A and solve in terms of W, right? So let's rewrite that. Minus A sine 60 plus A cos 60 is equal to minus W. And A cos 60 minus sine 60 is equal to minus W, right? Yep, that makes sense. Okay. So now we know that we just have to do, okay, let me just do that over here, I guess. Or actually, let me just try to squeeze it in really quickly here. So that means that A is equal to minus W cos 60 minus sine 60. All right. All right. So what is that? let's plug that into our calculator. So cos 60 minus sine 60. Okay. That gives us 2.73W, right? So we just solved for A. All right. Now what we have to do is solve for B, right? We've already solved for C, right? So we have A, we have C, we just gotta solve for B now. All right. So let me just choose a different color. And I guess let's do red. Okay. All right. So now we want to solve for B. Okay. So now that we have A, we can just plug that back into an equation. Any one of these equations, we can plug it into here, we can plug it into here, we can plug it into, I don't know, here, right? And we can solve, right? So I say let's plug it into here because B is already almost like isolated. We just have to divide both sides by sine 45. So then this just seems like the easiest. So let's plug A into 5. Let's do that. So B sine 45 is equal to W plus 2.73 W, right? Cos 60, right? So now we just have to isolate for B. So let's divide both sides by sine 45, like we said earlier. Sine 45, sine 45. And B is just equal to W plus 2.73 W cos 60 over sine 45. Okay. So let me um, plug that into my calculator. Actually, no, let me just isolate this a little bit more. So that means B is equal to, let's just pull out this like W factor, right? So W 1 plus 2.73 cos 60 over sine 45. Okay? So now we just have to plug this into our calculator, which is so much easier. And thankfully, that is 3.35, which is what I got earlier, 3.35W. So we also just solved for B. So we have A, which is 2.73W, B, which is 3.35W, and C, which is W. And that's our solution. Thank you so much for watching. Please don't forget to like, subscribe, share, everything. Thank you so much. If you have any questions, comments, concerns, you can email me or leave them in the comments, and hopefully I'll eventually get to them. I can't promise though, I'm super busy, um, but I can say that I'll try. Thank you so much. See you next time. Bye.